All right, team, listen up. This is your clinical crash course briefing. Today's target, hyponatremia. This is mission-critical intelligence. Sodium is the master of water balance in the body, and when it goes wrong, the consequences are absolutely catastrophic. Pay attention.
Hyponatremia is defined as serum sodium below 135 milliequivalents per liter. It is the single most common electrolyte abnormality you will encounter in hospitalized patients. A systematic approach is not a suggestion, it is mandatory.
Your first move, your absolute first step, check serum osmolarity. This is how you differentiate true hypotonic hyponatremia from the imposters. If osmolarity is high, it's a decoy. Another solute, usually glucose, is pulling water into the blood and diluting the sodium. If it's normal, suspect pseudohyponatremia, a lab ghost, an error from high lipids or proteins.
Once you've confirmed low osmolarity, you move to step 2, assess volume status. Is the patient dry, hypovolemic, from something like diuretics or vomiting? Your action is normal saline. Or are they wet, hypovolemic, overloaded with edema from heart, liver, or kidney failure? The playbook is completely different.
And what if they look normal? Euvolemic, clinically normal volume? Then your prime suspect is SIADH, that syndrome of inappropriate antidiuretic hormone. The body is retaining pure free water, making the urine dangerously concentrated. Most importantly, here is the golden rule, the one you do not break. Correct it slowly. Your target is a rise of no more than 8 milliequivalents in 24 hours. You have to understand, the brain has adapted to this low sodium state, and correcting it too fast will cause a catastrophic osmotic shift.
Or the pons will die. Know the water, save the brain. Let's go. Before we proceed, our mandatory international medical disclaimer. This content is for educational purposes only. It is not medical advice. Always consult official guidelines and a specialist physician for clinical decisions.
Sarah, nephrology starts with the physics of osmolarity. Students often panic when they see a sodium of 125 and want to give salt immediately. Why is serum osmolarity the absolute first branch in our decision tree?
Because it rules out the imposters, Dr. Collins. If the osmolarity is high, the sodium is low because a solute like glucose is pulling water out of the cells and diluting the blood. If it is normal, it's pseudohyponatremia from high lipids or proteins. We only care about hypotonic hyponatremia less than 280 osmoles because that is when the brain cells start swelling with water. It's an osmotic war.
Precisely, the brain hates hypotonicity. Now, once we confirm it's hypotonic, we look at the water tank. Hypovolemic versus hypovolemic. How do we tell the difference at the bedside?
Skin and veins. Dr. Collins, if the skin tense and the JVP is flat, they are dehydrated, hypovolemic. Give them normal saline to stop the ADH trigger. If they have edema and JVD, they are wet, hypervolemic. This means the heart or liver is failing. Both need very different treatments. But the most common board question is the normal volume patient. The euvolemic branch, SIADH. Why is the urine so inappropriately concentrated here? Because the brain, or a tumor like small cell lung cancer, is pumping out ADH without permission. The ADH puts aquaporins in the collecting duct, sucking back pure water. The urine sodium will be high, and the urine osmolarity will be greater than 100. The treatment isn't more water, it is fluid restriction.
Outstanding. Everyone check the resources for the Rule of 8 correction limit. Sarah, what is the lethal trap of fixing sodium too fast?
Osmotic demyelination syndrome, Dr. Collins. If you raise sodium faster than 8 milliequivalents in 24 hours, you pull water out of the brain cells so fast that the pons shrinks and the myelin shears off.
The patient becomes locked in, paralyzed but conscious. You must go slow to save the myelin.
All right, let's switch gears for a second. Time for our question of the day, and it's a clinical classic. Have you ever actually seen a case of beer podomania, that really unique hyponatremia from extremely low solute intake and heavy drinkers? We want to hear about it. Share your clinical finds in the comments below. Okay, Sarah, time for the sodium duel. Lock it in. Ready? Hypovolemic.
Next, hypervolemic is wet. Restriction.
Keep it coming. Euvolemic is SIAD, cancer.
And the most important one, fix it fast, pons will blast. ODS. Okay, sodium locked. Let's do a final mission debrief. Here are your key takeaways.
1. Sodium under 135 is your signal. That's hyponatremia. 2. Your first moves are always to check osmolarity, then volume status. And 3. The prime directive. Correct slowly. Stay under that 8 millimole Q in 24 hours ceiling to prevent ODS.
Excellent work. We've stabilized the patient. If this tactical masterclass was helpful, go ahead and like and subscribe to Clinical Crash Course and join our elite medical community.
In our next module, we're flipping the entire board around. We're going to see what happens when the water vanishes. So join us for hypernatremia and diabetes insipidus, also known as the desert in the blood. You don't want to miss it.